Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. Now, if my videos are very important to your studies to help you prepare for your future career as civil engineer, then please don't forget to subscribe. By the method of least work, determine the reactions for the beam shown below. EI is 40,000 kilonewton meter square. Joint A rotates 0.002 radian clockwise. So this problem was already solved by the double integration method and the force method. This time, let's solve it by the method of least work. So here is the figure, and this is statically indeterminate to the second degree. So let's make the redundance reaction at B and reaction at C. But before that, let's solve for HB and H sub C. So from the figure, so let's denote the redundance there. And this will be our sectioning. Then here, then here. So there are 5 sections, but in this section here, by the method of least work, the redundants are not involved, so we may bypass this portion. So there will only be 3 sections. From the figure, tangent of 0.002 radians is 0.002 radian itself equals opposite z sub b over 6 meters or 6,000 mm. So g sub b is equal to 12 mm. Since the settlement or the movement of support B is 30 mm downward, so g sub b is only 12 mm. Then HB is 30 minus 12, so HB is 12 mm downward. So because this is the final position of the support, that means that we need to move downward in order to locate the support here by 18 mm H sub B, and going down the displacement RB is upward, therefore we treat HB as negative because they are opposing. Then let's call that G sub C. Tangent of 0.002 is 0.002 equals G sub C over 14 meters or 14,000 mm. So G sub B is 28 mm. And since this is the final position of the support C, therefore the displacement H sub C, this H sub C here is 28 minus 20, so H sub C is 8 mm. Since this is the final position, and we assume that RC is upward, and H sub C is 8 mm also in the direction upward, therefore H sub C 8 mm is treated positive, or delta C is positive. So EI delta B is EI 40,000 times negative 0.018 HB treated negative 0.018 because the displace is downward and the reaction RB, one of the redundant forces RB, is upward, so it is positive, and therefore HB is negative. Is equal to integral. So let's begin with this section. Although it's 0, the derivative, the moment is 30 times x over 2 negative, or 15x, negative 15x squared. But anyway, that's 0. For the next section, integral from 0 to 8 of quantity R sub C times x minus 30 times 2 plus x. Then the moment arm is 2 plus x over 2, so that's why you have minus 15, 2 plus x squared. The derivative with respect to RB is 0 because there's no RB here. And for the next section, integral from 0 to 3 of RBX plus R sub C times 8 plus x, then minus 30 times 10 5 plus x, the moment arm. 30 times 10, then 5 plus x. The derivative of this equation with respect to RB is x dx. Then EI is constant, so there's no need to divide. Finally, plus integral of RB times 3 plus x, 0 to 3, plus R sub c times 11 plus x minus 30 times 10 times 8 plus x minus 60 times x. That's the moment equation. Then the derivative of this moment equation with respect to RB is 3 plus x dx. So the first value at the left side is negative 720. First integral here is 0, second 0. Then we have for the third, evaluate RB integral of x squared from 0 to 3, then that's the coefficient of RB. 9RB for R sub c integral of 8 plus x times x, 0 to 3, then for the constant. So 9RB plus 45RC minus 9450. Then for the last integral, that is 63RB plus 171RC minus 40,500. Combine like terms. Simplify. So the first equation is 72RB plus 216RC equals 49,230. Then EI delta C is 40,000 times, as I said, 0.008. This is treated positive because R sub C is upward and 8 sub C to locate the final support is also upward. So they are in the same direction, so positive. And it is partial of U, EI partial of U with respect to RC. So again, EI delta C equals 40,000 times 0.008 equals integral 0 to 8. Let's bypass that because that's still 0. We copy the moment equation, then derivative of R sub C dx is x dx this time. Integral of RCx is x, and differential of x. Copy the next integral, then replace this by 8 plus x dx. So rbx plus R sub c 8 plus x minus 300 or 30 times 10, 5 plus x, then 8 plus x dx. Then for the last integral, copy. Then replace this by 11 plus x dx. The partial derivative of this moment equation, 11 plus x dx. So integrating, the left side is 320. The integral, this first integral, RC and constant, 512 over 3 RC minus 27,520. For the next integral, 45 RB plus 273 RC minus 56,250. And for the last integral, 171 RB plus 471 RC minus 111,060. Combine like terms and simplify. So we have 216 RB plus 2744 RC over 3 equals 195150. Equation 2. Solving these two equations simultaneously, we get RB equals 149.825 just like before. R sub C is 177.975. Then for the rest, the same as in statics as before, so I will leave that to you. AX0, AY, then MA. So summation moment A, MA, plus 60 times 3, plus 30 times 10 times 11, and equals RB times 6, plus R sub C times 14. So MA equals negative 89.4 kilonewton meter. Finally, AY times 6, summation moment about B. So AY times 6 plus MA, which is negative 89.4, plus 30 times 10 times 5 equals 60 times 3 plus r sub c times 8. So ay equals 32.2. Then you check summation versus y if it is 0. So that is definitely 0.